Okay, so we're moving on to 7.3, and 7.3 is solving linear systems by what I call elementary row operations, also called Gaussian elimination. Tends to be kind of tedious, but it's things that you need to know. Okay, so right here, I am recording. Okay, right here you've got a system that's called a row echelon form system or a triangular system. Okay, forms like a triangle like that. And linear systems don't all come like this, so we got to do things to the linear system to make it look like this, and that's what Gaussian elimination is all about, and I'll teach you that in a minute. But the first thing I want to do is show you why this is a cool system, because it's easy to solve. Once I have z, I can take it in there and plug it in there, so I get y plus 6 equals 5, which gives me y is equal to 1. Now that I have y and z, I can put y in here and z in here and solve for x, and I get x minus 2 plus 6 equals 9, which gives me that x is equal to 1. So you can see it's really, really easy to solve linear system equations that are like that. Fortunately, equations don't come that easy. If they did, then my job would be too easy, and I don't like easy. All right, here's a system that we want to work with. It's not in row echelon form. It's not in triangular form. I got to massage it to put it in that form. Okay, so spend a minute, get those equations down, and let's start looking at how we massage this. I'm going to pause here. All right, so what are these massaging moves? Okay, so here they are. There are 3 different massaging moves. Read those. Make sure you have it written down. And we will be using these. These are called elementary row operations. A row is essentially an equation because, as you saw earlier, okay, going back here, these equations are all in rows, okay? And yeah, so you'll keep seeing the term row constantly in this section here, okay? All right, so spend a minute getting these down. Elementary row operations: interchange 2 rows, multiply one of the equations with a non-zero constant. Step number 3 is probably the most common use, okay? 2 and 3. 1's rarely used, at least not in the examples that we'll see in the book. Although it depends really also on your creativity. I mean, sometimes 1's very useful. All right. So let's take the original system and work on it. Now, the way these problems are done is very systematic and very stylistic, okay? What I mean by that is that you've got to follow the process. You've got to follow the process. So let me snip this guy. And go through some features that you need to know. So notice that the equations are numbered. You need to do that. Okay. Next, you give me the step number and tell me what you are doing in the step. Remember, my goal is to make this look like a triangular system. Okay. So there's only z in the last equation, y and z in the second one, and the top one is going to be x, y, and z. Okay, that's my goal. So right now what I'm trying to do is make this guy a 0, make that guy a 0, as you can see in here. And I'm doing it by following this step. This step reads, I'm going to take equation 1 and equation 2, add the 2 and put the result in equation 2. That's what this arrow means here. Put it in equation 2. Which means that equation 1 and 3 will be unchanged, as you can see. Equation 2 will be replaced by doing the addition of 1 and 2. So I can add these two, I get a 0. If I add minus 2y and 3y, I get a y. If I add 3z and a 0, I get 3z. If I add 9 minus 4, I get 5. Right? So this is the step you are taking. This is the resulting system. Okay, so I started out with this, and I come up with this. And again, remember, my goal is to make it look like a triangle. So my next goal, presumably, is to make this guy a 0. Okay, that would be my next goal, to make that a 0. Right, let's proceed. See if I can scroll this nice and easy and steady. So here we are. I'm starting out with the system to get here, and here's my step number 2. You can see that what that is. That's my step number. This is what I'm doing to it. So step number 2 is replacing equation number 3. Okay, so 1 and 2 should be unchanged, as you can see. 1 and 2 are unchanged. Step number 3 is obtained by taking the first equation, timesing it by -2, and adding it to 3. Now, if you can't do this step in your head, you might want to work this on the side. Okay, so -2 times equation 1 would look like -2x plus 4y minus 6z equals -18. And I'm adding it to equation 3, which is 2x minus 5y plus 5z equals 17. If I add the 2, okay, this cancels. This gives me minus y minus z equals -1, which is right there. Okay, this means that I'm taking the result and putting it in equation number 3. All right, so now I get a new system now. And again, the equation numbers are the same, 1, 2, and 3. I'm not changing those numbers, okay? All right. How do I go from there? So let me scroll down again and snip again. Let's see, I want a little bit more right there. Okay, so I'm starting out with this, ending up here. Okay. So my goal in this one is to make this guy a 0. Okay, and this is what I do. Here is my step number. Okay, that's my step number. And so since I'm replacing equation 3, equations 1 and 2 should be unchanged. And you can see that that's true. 1 and 2 are unchanged. If I follow this operation, which is saying adding these two, I can see that this will cancel to give me a 0 here effectively. This is going to give me a 2z. This is going to give me a 4. Now this is almost in a triangular form, okay? Well, it is in triangular form, but row echelon means that all the coefficients of the variables on the main diagonal, this is called the main diagonal, are all 1. And since this is not 1, I need to take the next step and divide the third row by 2.